Hello, friends, and welcome to this talk on space. Thanks so much for joining me today. There's so many aspects of space exploration that are interesting. I've put together a presentation of material from missions that I've worked on, and then some other things that I hope you'll enjoy. Feel free to share this with others, especially younger folks who I'm usually talking to when I make talks like this. Thanks to our online on-demand format, you can move around easily back and forth and pause anytime you want. And I've put in title pages of the various sections to help you find different parts of the presentation. Again, thanks so much for joining me, and let's begin our journey. Okay, so I'm an aerospace engineer, which means that I design spacecraft. I work with a team of people to figure out what the spacecraft will look like, the parts that will go into it. I focus on the mechanical or the structural parts of the spacecraft. I also help to assemble the spacecraft, to test it, to make sure it's going to work properly, and to help with the launch. I've had the great privilege of working on many different types of spacecraft, which are tools that serve people in different ways, including understanding the Earth, providing information that we can use in our daily lives, and exploring the universe. In the 1950s, when my father was at GFS, space exploration was science fiction. And when I was at GFS growing up, that became reality through the landing on the moon, the Skylab mission where people stayed in orbit for a long period of time, and many other missions that helped us explore the universe. 1968 was the first time that people orbited the moon, and not only that, but were able to see the entire Earth for the first time. A very defining moment, and made pictures that have inspired people ever since to focus on protecting the Earth and many environmental efforts. This picture is extremely famous. I'm sure you've seen it, but kind of highlighting the fragility of the Earth relative to the starkness of the moon. Last month, we once again celebrated Earth Day, and that day every year is a great reminder of the importance of protecting the Earth and its fragility. As a kid, I flew model rockets as a way to learn about rocketry and many other things. You could see my sister there in the lower left helping me out, getting ready for a launch. And that was not only just a fun activity, but I learned quite a bit of it. You know, how important it is to pay attention to details, because that'll make a difference on whether the rocket flies straight or does something else. Many times my rockets crashed or landed where they weren't supposed to, so learned how to deal with failure and learn how to follow proper procedures to make sure that I did the launches safely. So my experiences at GFS were really so critical in my development that I want to highlight them here. And ninth grade in particular was an important year for me. The encouragement and support from my GFS teachers was really key to my development and my ability to move forward from that time. I remember biology class and science and music and theater, all those things just really helping me increase my confidence and help me commit to really being a good student, which I wasn't always the greatest student. So the support from GFS teachers and staff, in addition to my family, was so important in my development. Here's some pictures of the GFS science teachers who helped me so much during that time. I want to particularly highlight Herb Basso, chemistry teacher. He really cared so much for his students. He worked to improve teaching methods for chemistry, and he was really concerned about the environment. One of the particular things he was concerned about was ozone loss and the effect on the environment, and we'll talk about that more in a little bit. For my junior project, I installed a lighting and sound system in the Yarnell Auditorium. I got some great experience from that project, Had much help from the school staff, my father, many friends, and taught me a lot of things about managing a project. Uh, how to keep it in the cost budget, how to stay on schedule, and how to meet your commitment. And that project, you might remember, was for a month, and it took me the whole month to get it done. Um, the point of that project was to enable the Yarnell Auditorium to be used for plays and other productions. At that time, we were really starved for space. Poli Auditorium was very busy, so that allowed us to do some productions that we wouldn't otherwise have been able to do. And it actually, that system worked until just a couple years ago when it got replaced. But the point is that it was a great way for me to use my skills to serve others. Here's some pictures from when I was doing that project, courtesy of my father, doing a whole lot of wiring, and you can see cables all over the place in that left-hand picture. The experience of working with the team in a theater production, running the board, doing the lights as a part of that production was just really a wonderful experience. And on the right-hand picture, very crude way of making sure that the lighting bar was going to be strong enough. Somebody asked me, how do you know that's not going to fall down? So the test was to hang myself off of it and say, well, if it's strong enough to hold me, then it's going to be strong enough to hold the lights. And like I said, that lasted for quite a few years. Going to college, my initial idea was to study electrical engineering, which was my father's career. I remember writing an essay that said, essentially, I want to build things that will help people, really keying off of my experiences with the junior project. But I decided to change to aerospace engineering my first year. Basically, one of my big motivations was the first space shuttle flight, which occurred the spring of my freshman year. Very, very exciting seeing that new vehicle fly, and not only the idea of the vehicle flying, but all the things that were planned for it. I was really excited about all the experiments that they were talking about, and one of the big ones was a space telescope that could be launched in the shuttle and do astronomy from space. My work in the college lab was basically doing research on lightweight materials. Those materials at the time were considered fairly exotic. Now they're very commonplace, both in airplanes that you might fly on if you're traveling, and in the spacecraft that I work on now. So what's a spacecraft, in some more detail? Basically anything that leaves the Earth's atmosphere, whether it's flying around the Earth to provide scientific information, whether it is a telescope looking out into space. There's many probes that have gone to other planets, as you know. Many satellites provide vital communication services all around the Earth. We have our GPS satellites for communication and many other types of satellites. Another type of spacecraft is spacecraft that people can be in, like the ones that go to the International Space Station. I've mostly worked on essentially robotic spacecraft that don't have any people in them, except for a couple of shuttle missions. Okay, now we're going to talk about spacecraft that look at the Earth. So information from spacecraft that observe the Earth has really become indispensable, from the everyday data for weather forecasts to information that we use in many aspects of our society and industry in other ways, and in understanding the climate and how we need to protect the environment of our Earth. An example of information from satellites making a major positive impact is ozone loss. You may have heard of this topic, but in the late 1970s it was found that the ozone level in the upper atmosphere was decreasing. Ozone is very important because without that chemical in the upper atmosphere, the ultraviolet radiation from the sun would come through, and the radiation's levels would be lethal. And through a bunch of studies, chemists determined that chlorofluorocarbons, or CFCs, were destroying the ozone, or were suspected of destroying the ozone at that time. And that was a chemical that was really widely used in refrigeration, in spray cans and air conditioners, and a whole bunch of other uses. One of the main tools that was used to identify ozone loss was the Nimbus 7 spacecraft built out in Valley Forge. Over just a couple-year time frame of those observations, which used the first ozone sensor on a spacecraft, it was very clear that the ozone levels were decreasing, and particularly over the South Pole, the ozone hole that you see in these pictures here, but over many areas of the Earth, it was clear that ozone was decreasing, and that was a major concern, which led to an international agreement called the Montreal Protocol that banned most chlorofluorocarbons. And now we have benefited from that because those emissions have been greatly reduced. The ozone loss is expected to eventually reverse. It's kind of leveled out now, and it's a huge success story. It's really chemistry at its best, serving the general public and people all over the world. There have been some studies that have predicted what would have happened if we had not reduced chlorofluorocarbon emissions, and the predictions were actually extremely frightening. You can see where we are in 2021. At that point, the predictions indicated that the ultraviolet index, or the amount of radiation coming down to the surface, would have been increasing, and increasing exponentially, which is typical for this kind of behavior. So we would have already now been seeing very serious health effects, and they would have gotten progressively and rapidly worse and worse. So really a great success story of identifying that concern and nations working together to combat it. I was able to work, my first job actually was working on a spacecraft called UARS, the Upper Atmosphere Research Satellite, which was launched on the shuttle. That satellite was the first to provide conclusive evidence that human-made chemicals, i.e. the CFCs, were destroying ozone. That spacecraft worked for several years. And since then there have been a number of satellites, and one still working, that are keeping an eye on the ozone layer and showing that the ozone levels now are stabilizing and hopefully will recover. Now I'd like to talk to you about one of the missions that I really am the most excited about in my career. It's called Terra, and it's a climate research satellite with many sensors that look at the Earth in different ways. The name Terra came from a contest where a high school student came up with a name that turned out to be very appropriate. And this was also built out right near Philadelphia in Valley Forge. I worked on many aspects of the mechanical design, and specifically what we would call the skeleton, or the structure of the spacecraft, that used lightweight materials like the ones that I studied in college that I told you about. Here's a picture of us building the spacecraft. There's a lot of different things that go into a spacecraft like this, not just the sensors, but all kinds of different electronics, wires. The gold material is protection for basically from the sun, for thermal protection. And you can see us wearing our white suits, you'll see more of that, to protect the spacecraft from contamination. Working on satellites really is a team effort. You'll hear me say that over and over. This is just a small part of the team that assembled the spacecraft and got it ready for launch. If you can find me in this picture, you'll get a prize. Getting it ready for launch, you can see us putting Terra into the nose cone of the rocket, and then taking that nose cone and lifting it up into a huge building that's enclosing the rocket. So we lifted that nose cone up, brought it through that big door, and attached it to the top of the rocket. Then when we were ready for launch, He opened all the doors, and you can see the rocket with Terra on top of it, sitting there on the left-hand picture, and then that entire building rolled away to make it clear for the rocket to launch. So back in December of 1999, I had worked on the program for almost 10 years, and others had worked on it even longer than that. This picture is me in that tower building, and you can see the tip of the nose cone in the background. And the next day, we launched. Here's some pictures that show, computer pictures that show how Terra takes its data. It is in a polar orbit that goes over the poles, and it takes data in strips, and that data is put together in a computer, processed and distributed in different ways. When we first saw the image from Terra that first came down, which is on the left, it was a very emotional experience. Down in the control center in Maryland, you can see me there and a bunch of my colleagues, and I cried. I was so moved by seeing the results of our work coming down on the screen, and just a very, very fulfilling moment and a reminder of that team effort to make that happen. Here's a couple images called Blue Marble images made from the information from Terra. And here's a little video that'll show you some information about the Terra mission.
7, 6, 5, 4, 3, 2, 1. Main engine start and liftoff of the Atlas rocket with Terra, flagship of the Earth Observing System.
Okay, here's some examples of a few of the things that were shown quickly in the video that you just saw. The vegetation activity plot is really interesting because you can see going from the summertime in the north to the summertime in the south, back and forth. This is an indication of basically the vibrancy or the potency of vegetation, which is almost like in a way of measuring the health of the planet. You can see on the lower left picture of pollution that we'll talk about in a minute, and a global fire map. All those things, very important data from Terra. We're all very aware of the wildfires that seem to happen every year now. Terra is one of the main instruments that are used to understand where those fires are and help to direct fire prevention efforts, whether it's in different ways. You may remember back in 2019 there was a huge concern about fires in the Amazon and in South America. This is a picture from one of the instruments on Terra looking at those fires during that time. In the little graph you can see how the red line, the amount of, there's fires every year in South America and other parts of the world, but you can see how in 2019 they were significantly more than normal. Measuring pollution, obviously very important. There's a sensor on Terra that measures carbon monoxide, and that can come from natural sources or for human activity. For example, I'm highlighting pollution from urban activity in China. You also see a big red spot on Africa that is wildfires and some human-made fires that occur every year. So we can use the information from Terra to understand where pollution is occurring, and in some cases to be able to take action to control it. Can also measure basically the moisture level of the earth. Soil moisture data is really important and can help to provide warnings when a drought is likely to occur so that farmers can take protective measures. And another application that I think is fascinating is trying to predict where diseases like malaria are likely to break out. Again, it's related to soil moisture data. And the opposite of the drought that we just talked about, if there's indications where there's going to be high levels of soil moisture, that basically can be tied to mosquitoes that can transmit diseases like malaria, and again give people and health programs information to take preventative measures. So very innovative ideas of using this data that we never even thought about when we were building the spacecraft. There are two instruments called Ceres on Terra that measure basically the radiation budget, the amount of radiation that comes into the Earth and comes out of the Earth. Ideally, that budget or the amount of radiation coming in and out is balanced so that the Earth's overall temperature maintains relatively stable. These instruments are very, very sensitive, and you can see one of my friends there in the bottom doing an inspection right before launch, making sure that there's no contamination and the instrument will operate correctly. So those observations have been going on since 1999, and there was just a very important article that was put out that confirmed that basically human activity is throwing that energy balance off balance, that our activity is changing the Earth's energy balance, and that's a very important aspect of understanding climate and predicting climate change. So a really, really important finding. That's just one of many, many findings from the instruments on Terra. And then here you probably have seen some plots like this, but looking at the colored bars are indicating the average surface temperature of the Earth for a long time. And we all know that that temperature has been going up and up and up. Every year it's pretty much a record. And also looking at the gray line, which is the concentration of carbon dioxide. So data for a plot like this comes from many different sources, including Terra and other satellites. I just wanted to show you a picture of some more of my friends that helped put together Terra. We had a fantastic team, and we just got together for the 20th anniversary. Because Terra has lasted so long, over 21 years now, it was originally going to be the first of 3 satellites. The 2 and 3 were never built, but Terra is still working very well. And it's really important to have a consistent set of data over a long period of time. Climate scientists are very, very interested in it. There's a huge amount of publications from Terra data, and it's really These words are not mine, they're somebody else's. Basically, it's a monumental climate data record that's unparalleled. So as a result of that, one of the recent NASA subcommittees said that Terra is perhaps the single most important NASA Earth science mission ever. So really a very, very important mission. And Terra is only one of many satellites that are helping us understand our Earth. It's part of the fleet of satellites that NASA and other countries are using to help us understand the Earth in many different ways. And here's yet another picture showing our wonderful team. Now we're going to switch our focus away from the Earth and look at doing astronomy from space. So the Hubble Space Telescope, one of the most important scientific instruments ever built, is 31 years old. And that's a tremendous age for a spacecraft, and it's been able to operate for so long because it was repaired and upgraded using the space shuttle. There were 5 missions that did that. The final servicing mission was in 2009, and I was privileged to work on that mission. I worked on a structure that you can see in the top of this picture, which shows all the equipment that went up on that shuttle mission. The structure I worked on carried the Wide Field Camera 3, which is really the most important instrument that's on Hubble right now. In addition to that, some new batteries for the telescope and a bunch of other equipment, and then there were a number of other items that were either replaced or upgraded during the mission that you can see down in the bottom in the picture. So that was launched in May of 2009. My dad and my wife and I were able to be at the Cape and see that launch, very exciting. You can see the carrier structure in that orange color in the middle picture that I worked on, and one of the astronauts preparing to remove the Wide Field Camera 3 from its protective enclosure. And then over on the right-hand side, the astronauts installing the camera into the Hubble Space Telescope. Extremely exciting and successful mission. Now I'd like to just show you quickly some of my favorite pictures from Hubble. These pictures are awe-inspiring in their own right, and they're also of great scientific interest. A lot of the most interesting ones are nebulas, which are created by exploding stars. Here's a particular one that, because of the way the star exploded, it gave the shape of a butterfly, which is really cool. Another couple of nebulae. The one in the center looks almost like a bowl, and the area in the center of that bowl is a very, very hot area where stars are being formed, where you have these really hot areas where the material is very dense and packed closely together. That's where stars basically accumulate material and start their lives lighting up, so to speak. Here's another very impressive picture of a star that, again, blew up, produced a cloud of gas that's being illuminated by the remains of the star, and this star is 70 times the size of our sun. Huge. Just awe-inspiring picture. Some of the pictures that are taken are not just of a single star, but of big areas of space. This particular area has a wide range of stars of different temperatures indicated by the color, and also different ages. So when they take these surveys, that helps astronomers understand the life cycle of stars. Obviously, stars aren't alive like a person or an animal is, but they have a beginning where they start up and start illuminating through fusion. They evolve through their life, and then they end their lives either by blowing up, by fading out, or different ways depending on the size and the temperature of the star. Here's a wonderful picture that shows different galaxies. Just wonderful seeing the different diversity of patterns of galaxies. Often they're spirals or wheels of some kind, but they're all different. Here's another galaxy that's in a wheel shape, and you can see the bright areas are, again, stars being formed. Here's a different kind of picture from Hubble, which has been used at looking at planets in our solar system. This one is Jupiter. Jupiter got hit by an asteroid in 2009, very shortly after that surfacing mission, and that asteroid had ripped a big hole into the clouds of Jupiter, and over time the clouds essentially healed or covered over the hole to the point where at the bottom image you can see that you can't tell that the asteroid ever hit it. Really interesting, and also important to scientists understanding the dynamics of Jupiter's atmosphere. Here's just another beautiful picture showing areas where stars are being formed. And one of my favorites, the ultra deep field. This is basically an area of space that Hubble looked at over a long period of time and collected very, very faint light from very, very far away galaxies and stars. And from that, they were able to find the star that is considered the farthest star, at least that we've seen so far. And that was used to predict or determine the age of the universe at approximately 13.8 billion years. They're continuing to do these kind of surveys, and they update that number all the time, but that number is basically close to, very close to what they believe the age of the universe is. Now I want to switch our focus back to the Earth and look at how satellites can be used to monitor our weather. So recently I've been working on a new series of weather satellites called GOES-R. And these spacecraft are very important for weather forecasting and a number of other uses. These satellites, different from Terra, operate in a geostationary orbit. That means that the spacecraft moves along with the Earth and its view remains fixed all the time relative to the Earth. Here's a little cartoon that illustrates the importance of keeping the spacecraft and the instruments really, really stable. If you think of taking a picture with your cell phone or with a camera, it's hard to take a picture of something that's far away because it's hard for you to hold that camera stable unless you have a tripod or something to help you hold it. In this case, our camera is 22,700 miles away from the Earth, so it needs to be extremely stable, and not only that, it needs to point at the right direction all the time. So in order to do that, we need a very, very stable platform that holds the instrument and also holds an instrument called a star tracker that tells the spacecraft where it's supposed to point. So that structure has to be very stiff, it has to not move, and it has to keep its shape. Over the course of a day, the spacecraft can be a lot of the time in the sun, so the sun is blasting it and heating it up. And then other parts of the orbit, you're shadowed from the sun, so the spacecraft gets very cold. If you use normal materials, the platform and the spacecraft would warp and bend, and you'd get a situation like this where your instrument is not pointing in the right direction and the image will be blurred. So we use, again, the special materials that I told you about to make sure that that platform remains very, very stable and we're pointed in the right direction and our images remain very clear. When we go to work on a spacecraft, like I showed you before, we have to get suited up to the point where the only thing that you can see is a little part of our face with our eyes. That's to protect the spacecraft from getting contaminated and also to protect us. Here's a picture of us lifting the instrument platform that I designed over the spacecraft, and we're going to bring it down and set it down on top of the spacecraft. And then after the platform is safely on the spacecraft, we attach the instruments and the sensors that are going to do the mission of GOES-R. This is the primary Earth camera. It's very, very expensive, over $1 billion. So obviously we handle it very, very carefully. We bring it down very slowly with people that are very well trained and know what they're doing. Bring it down slowly and attach it in a very stable manner so that it'll remain stiff and stable like I showed you in the little cartoon. Gozar also has a sensor called a lightning mapper that's shown in this picture. I like these pictures because not only are they showing the instrument itself, but they're showing some of the great people that I get a chance to work with. The folks that are sitting there with me have worked very hard to build the instrument and test it at their own facility, and then we bring the instrument to the spacecraft and working together as a team do the painstaking work of attaching it so that it will do its job. Really, really excellent team effort. Here's a fun picture that I like of, we have many things that we use, fixtures and equipment that we use for handling the spacecraft in order to work on it in different ways. Sometimes we have the spacecraft standing up vertical, as I showed you before, or we can rotate it so that it's horizontal. And when we rotate it to horizontal, all the stuff that I designed, the platform and all the attachments and connections that bolt everything together have to work, because we don't want that $1 billion of instrument to fall off the spacecraft and end up on the floor. So this is a picture of the first time we rotated the spacecraft. Even though I hadn't done all the calculations and I was very confident, it was still a little nerve-wracking seeing this thing rotate over and knowing that if I did something wrong, we would be in a big lot of trouble. But luckily everything worked exactly the way it was planned and there was no problem. We did our job correctly. We do many tests before we launch to make sure that the spacecraft is working properly. The environment in space and also in launch is very harsh, so we need to make sure that the spacecraft's going to work after it's been exposed to those environments. The left picture shows a thermal vacuum test. It's basically a huge thermal vacuum chamber where we can remove the air and heat up and cool down the spacecraft to simulate what it's going to see on orbit. Sometimes that's called the torture chamber because it's very hard on the spacecraft, but that allows us to demonstrate that everything is working properly. And if something's not working properly, we can fix it before we launch. On the right-hand side, we do several tests to simulate the launch environment, which is very severe. If you think of a rocket launching, it shakes very violently and there's a huge amount of noise from the engines. This shows an acoustic test where we blast the spacecraft with very loud acoustic noise, and that shows that the spacecraft can survive that really hard environment. Another test we do is we have a lot of things that are folded up so that the spacecraft fits into its nose cone, and those have to unfold on orbit, otherwise the mission will fail. So very critical test showing that solar panel that's been folded up for launch will properly extend and fold out so that it can generate that electricity that's critical for the satellite. And the platform that I showed you a few slides ago, we do a special test where we essentially simulate what it's like when it is in zero gravity. That's a very important test to make sure the instruments are going to be stable, and we need this very complicated machine that you see over on the left-hand picture to simulate that mechanical condition in space. And all the time you have to make sure everything is correct. You spend a lot of time inspecting, checking, double checking, because once you launch, we can't fix it. It's not like Hubble where we can go up and make a repair. Everything's got to be perfect. So here I am right before we sent GOES-R to Florida for launch, just making sure that everything's the way it should be. Watching a launch is really exciting. If you ever get the opportunity to go to Florida, I highly recommend it. Here's some fun pictures of when we watched the GOES-S launch, joined by my dear family, some friends, and in this case, Dana Weeks and her husband Bill were able to join us. Seeing me and my dad on the left, and then my sister Lisa over there on the right. And in the bottom center, you see the whole crowd looking way over. It's about 6 miles away to where the rocket is getting ready to launch. And here's a video of that launch.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Launch director.
You have permission to launch.
Proceeding with the count.
3, 2, 1. And liftoff of the Atlas V and NOAA's GOES, a highly sophisticated weather-watching eye in the sky, to join its twin in providing better forecasts and saving lives.
Roll program is complete. Execute. And we have indication of SRB burnout. See, it looks like a clean separation. And we have indication of spacecraft separation.
When you see the satellite separating from the rocket, like you can in this really dramatic onboard camera picture, you know that the rocket has done its job and now the satellite is ready to go do its work. So there's 2 spacecraft that are now operational, GOES-R covering the eastern US and GOES-S covering the west. We're now working on a spare called GOES-T that we're planning to launch in December of this year. So again, very emotional moment when you see the first pictures from the spacecraft. But one of the things that's really exciting is that the data from GOES gets to the National Weather Service in 20 seconds or less. And it's sent all over the world. All the different countries cooperate so that they can get the information out and make weather forecasts that are as fast and as accurate as possible. If you go on the internet, you can actually get pictures from GOES that are almost real time. Very cool. The GOES sees different wavelengths of light, and the meteorologists use the data from all the different wavelengths in a lot of different combinations to track and to predict weather. One of the things that GOES does a lot is track hurricanes. You all know that there's been a lot of hurricane activity and it's getting more severe and more often. So GOES tracks those storms and gives warnings that save lives. Here's an animation of real lightning mapper data from that instrument I showed you. The yellow dots are lightning strikes, and you can see them forming very, very strongly, that storm front that's going across, showing the storm moving. The lightning flashes often indicate where tornadoes can form, so it's a very, very important bit of information or type of information that is very new, and the meteorologists are very excited about that. So a lot of work is done to make sure that the data collected by the spacecraft is valid. In order to do that, they take measurements of the same target at the same time with multiple instruments as double checks. So the same time you're taking a picture or an image from GOES, you take a picture from an aircraft, you look at the measurements from ground stations, and you put all those measurements together and compare them. And you make adjustments as needed to make sure all those results are as consistent, as valid as possible. For GOES-R, which was the first in the series, that validation lasted almost a year before they declared that they were totally confident that the data coming from the spacecraft was fully valid. So a lot of work is done to make sure the data is credible and it's right. You've heard a lot about weather computer models. They talk about them on the weather forecast. There are many of these different sophisticated computer programs that produce weather forecasts. You can see 3 of them here. The first one that's shown there, the ECMWF, is the European model. Then you have the North American model and the GFS, which is the Global Forecasting System. That's basically the primary American model. So they take data from the satellites, from all different satellites, feed them into the models, and that's used to generate forecasts like you can see in that little future weather picture from one of our local stations down at the bottom. Meteorologists, have preferences on which models they like to use, and they'll consider that as they make their forecasts. In recent years, the European model has been considered a little bit more accurate than the GFS or the American model, but folks at NOAA who run the GOES program are doing a lot of work to increase the accuracy. They just did a big update recently, so hopefully the GFS model will get to the same level of accuracy of prediction and even get better and better over time. Something that struck a little close to home for me was Hurricane Maria. That hurricane struck the Caribbean in 2017, including Puerto Rico. Very, very severe storm, and as you can see in this picture from GOES-R, it went right over the island, and as we know, did severe damage to many different places, not just Puerto Rico, but that was one of the areas that was hardest hit. Down in the lower right-hand corner is a kind of a false color image showing the severity of the storm. Very, very severe as it went over Puerto Rico. And during the storm, when basically all the ground-based equipment, the radars, were knocked out, they were actually using the GOES-R data directly to provide information as the storm progressed. A bunch of folks from my church in Germantown went to Puerto Rico the next year. You can see even then at that time the level of devastation that occurred because of the storm. They're still doing repair work and recovery, and obviously many other places are hit by these storms, and the weather or the data from these satellites we can't prevent the storms, but we can try to warn people and minimize the damage or minimize the loss of life. Another interesting device that's on GOES-R is called the Search and Rescue antenna. That allows people that have a device, or ships, aircraft, other things, to send a distress call that's received by the satellite, and then that's set down to the ground, and then they can direct rescue operations to go and help whoever's in trouble. Many lives have been saved by this program. There are antennas flying on several different satellites, but GOES-R has the most powerful one, so there's already a number of lives that have been saved through the use of that system. And finally, GOES-R just doesn't look at the Earth, it also looks at the sun, because the sun is very important in our weather forecasting. It's very, very dynamic. This picture you can see, you can get an idea of the amount of activity on the sun. Can often be violent. You hear about sunspots and solar flares and stuff like that. That activity affects our communications on Earth, and it also really affects satellites and things that are in orbit. So having good information about the sun is a critical part of the GOES-R mission. Now I'd like to talk to you about some space stuff that I have nothing to do with, but I think is really interesting. And it's focused on the International Space Station. So now we have at least 6 crew continually on the station. They stay for 6 months or more. And the station is a laboratory for experiments studying, number 1, the effects of space on people over the long term, and also very importantly, experimenting ways to make, build, and grow things in space. There's women and men from many different countries that are working on the space station now, and a big part of that is essentially practicing for what people need to do in order to live in space for a long duration. Here's a picture of the space station with the big solar panels at the ends and the areas, the modules where the astronauts live in the middle. And as I mentioned, a major part of the work is experiments of all different kinds. Every mission that goes up carries a different set of experiments that are to be done. And the key is using the weightless environment in space to make materials and do experiments that can't be done on the Earth. There's a lot of interest in making medicines and pharmaceuticals that can be done and processed in a different way, sometimes faster in space, creating different materials and seeing how they work in space. Huge amount of work is done in basic science and applied science like medicines. Another interesting part is learning how to grow plants in space. In order to live in space for a long time, we need things to eat, and plants are a way to do that. So there's a lot of experiments on what types of plants will grow well and are a good source of food, and also producing oxygen on the space station that the astronauts need to breathe. This is a fun picture. There's an area on the space station that has these beautiful windows that the astronauts use to take photographs of important things on Earth, and also just to hang out. The astronauts are very busy and they work very hard, but sometimes they get a little time off and they can go up here and take a look out the window. As I mentioned, there's members of the crew that come from all over the world. Back a couple years ago, we had the first all-female spacewalk. The astronauts, when they are working to repair and upgrade on the outside of the space station, they generally work in pairs. In this walk, they were doing some work to upgrade the space station's power system, very important. That's work that's ongoing, but you can see that was a very successful walk, and they were really happy when they got back inside. Now we have a new way to get to the space station using a capsule built by SpaceX called Crew Dragon. The Crew Dragon capsule launches on a Falcon 9 rocket from the same launch pad that was used to go to the moon and for flights of the space shuttle. Here's some photos of the first Crew Dragon launch with astronauts on board. The first stage of the Falcon 9 rocket comes back and is reusable to save cost. On orbit, the capsule separates from the second stage of the rocket, and then it automatically completes its journey and docks at the International Space Station. Very happy moment when the crew leaves the capsule and joins the other crew on the International Space Station. This is the first crew that launched on Crew Dragon. Flights are controlled by mission control centers in Houston and one run by SpaceX in California. For the first launch, they had great commentary from several different astronauts, and I really like this one from astronaut Leland Melvin, who after the successful launch said, "This is what shows what Americans can do when we come together as a team. This is what it's all about." And it really is what it's all about. Working together for a common goal. The most recent Crew Dragon launch took 4 astronauts, the ones that are shown in black here, to the International Space Station just a week or so ago. At that time, there were 11 members of the crew from 4 different countries on the space station. I just want to highlight the international cooperation that's a real big part of the space station program. The amount of coordination and cooperation that's needed for all these different countries to work together effectively has really worked out very, very well, and it's a great example of how we can work together with different countries. The crew of Crew 1, the earlier crew, just left the space station, and early this morning, as of this recording, they've landed safely back on Earth. I thought it'd be fun to talk a little bit about exploring Mars. One thing to keep in mind about Mars is that we only have a window to launch to Mars about every 26 months, and that journey takes about 9 months. So before you can land on Mars, you need to get good information on where to land. I had the opportunity to work on Mars Global Surveyor, which was a mission that took many, many pictures of the Martian surface and was used to study the geology of Mars, but also to pick landing sites for some of the landers. I worked on those solar panels that powered the spacecraft. In addition to looking at the surface, it's also important to understand Mars's atmosphere, which is very, very thin, but it does have an atmosphere, and understanding it is very important for planning the current and the future missions. I worked on the antenna that beamed back the data from MAVEN, and that's still working very well. So more recently, we've had the joy of hearing about Perseverance. So Perseverance is the younger brother of an earlier rover called Curiosity. They both landed successfully on Mars. Perseverance landed in February of this year, and their mission is to explore Martian geology and also to look for signs of ancient life. And when we're talking about life, we're talking about at a very, very small molecular level. One of the great things that's been discovered on Mars is water below the surface. When I was growing up, there was never any idea that there was water on Mars. We thought it was just completely dry. But it's been found a number of times now that there is water on Mars, and there's great evidence of past water on Mars, which is considered critical to having the conditions that could support life. So Perseverance, again, is similar to Curiosity, but has even better tools and sensors to study the Martian surface in different ways. You can see pictures with all the cameras and tools that dig into the soil. Perseverance is actually going to take some samples and leave them on the surface to be picked up by a future spacecraft that can bring them back to Earth. So that's really exciting. So Perseverance had to launch and land in the middle of our COVID-19 pandemic. I know all of you, or many of you, have had to work or support your families under very trying conditions. I really like this picture because it showed members of the Perseverance team working from home, sometimes with their kids or other company. But nevertheless, they overcame all those difficulties. They launched successfully and they landed successfully. So just an absolutely fantastic and inspiring effort. One of the cool things about Perseverance is that it carries a little solar-powered helicopter called Ingenuity. That helicopter, it's very, very exciting. And as of my recording here, it's flown 4 times now. A friend of mine was part of the team. I had nothing to do with it, but a friend of mine was very involved, in particular in the mechanisms that you see in the lower right that held the helicopter during its mission and then released it and let it drop to the Martian surface so it could do its job. So now I'd like to show you a little video about Ingenuity.
Earlier today, Ingenuity should have autonomously performed its first flight attempt on Mars. Now the team is ready to receive the data that will tell them whether we've made history.
This is downlink. We are beginning to see data products.
Rotor motors appear healthy. All actuators appear healthy.
Ingenuity is reporting having performed spin-up, takeoff, climb, hover, descent, landing, touchdown, and spin down. Altimeter data confirms that Ingenuity has performed its first flight of a powered aircraft to another planet.
We can now say that human beings have flown a rotorcraft on another planet. Let's get back to work and more flights. Congratulations.
One of the things I like about working for NASA is their deep commitment to diversity in a number of ways. That's why I like this picture. I found in my career that a wide range of ideas and perspectives is absolutely essential when you're solving complex problems and in order to collaborate and make your team successful. An example of that is the first image of a black hole, which came out a couple of years ago, extremely exciting. I love showing this to students when I talk to them, and they're always very interested and ask a lot of questions about black holes. And that image was put together by the combined effort of astronomers around the world who took data and put it together with the data from their counterparts to create this stunning image. Really an inspiring team effort. Here's some reflections that I like to share with students when I speak to them. First, emphasizing what we've spoken about a number of times. Working together as a team and communicating within that team is really, really important. Another thing is that you don't have to be the smartest person in the group, but your effort and dedication are really, really important. As well as diversity, as we've just spoken about, and the willingness to take risks and to learn when things don't go the way you expect. Oftentimes, we learn a lot more when things don't go the way we expect than if they just go smoothly. So that's an important part of the engineering process. And especially with these missions that may take years or decades even to develop, you have to be very persistent and have perseverance to take things to the finish line and make sure everything works. And behind this all is a reminder that our missions are providing a service, whether it's to people in our country or folks around the world, the idea of service in our work and in other parts of our lives. So what's next? There's some exciting missions coming up that I'd like to share with you. The first is the James Webb Space Telescope. This is a new telescope that'll provide much sharper and higher resolution images than Hubble does right now. One of the reasons that it'll be able to do that is that it'll be far away from the effects of the Earth out in deep space, and it'll use some very sophisticated technology. Part of that is the actual telescope part. You can see here the main mirror and the optics part of the Webb telescope, which was put together down at the Goddard Center in Maryland. And I was really happy to be able to share a look at that part of the telescope while it was at Goddard and before it was shipped to be assembled to the rest of the spacecraft. Right now they're doing final tests on the James Webb Space Telescope, verifying that it's ready to go and it's being prepared for launch hopefully later this year. So really looking forward to what should be some stunning images and some fantastic scientific information for astronomers. Meanwhile, I'm working on another new space telescope, and that telescope is named for Dr. Nancy Grace Roman. Well, Dr. Roman was the first chief astronomer for NASA starting around 1960, which was really groundbreaking, especially because she was a woman. But her skills in astronomy led her to that position, and as the chief astronomer, she worked on planning a number of space telescope missions leading up to the Hubble Space Telescope. So for her pioneering leadership, she's considered the mother of the Hubble Space Telescope. She had to overcome many obstacles. There were many folks, including her college professors, that didn't think that she'd be able to take on this work, but she did, and she was very greatly respected during her lifetime. That's why I'm really inspired to be working on this mission named in her honor. But here's a little video that tells a little bit about this new telescope. So as was mentioned in the video, Roman is designed to basically have the same resolution as the Hubble Space Telescope, but to be able to see 100 times as many stars at one time. This is really important to be able to survey large areas of the universe. One of the basic questions that astronomers are struggling with right now is that we only think we can see about 5% of the energy and matter that is predicted to be in the universe. So that's a major discrepancy in all the astronomical theories, and the Roman Space Telescope is intended to try to find some of this missing matter and energy by doing these very large area surveys. It's very high technology and very challenging to be able to survey an area this large with that same level of information as the Hubble. In addition, Roman is going to be looking for planets around other stars and other solar systems. So that's another really important part of this mission. So very exciting to be working on the Roman Space Telescope. It's going to be several years before we're ready to launch, but I'm looking forward to it and the discoveries it's going to provide. Okay, well, that's the end of my talk. I'm very appreciative of you for listening to this presentation, and I'd like to make a couple acknowledgments to my family, and especially my father, Tom Dinardo, class of 1954. Also, I'd like to express my appreciation to Brandon Jones, our Director of Alumni Relations, for his help with putting all this together. Thanks to you all. Here's some links of information that you might be interested in. If you hit pause, you could jot them down, or if you'd like, you can feel free to contact me at this email address. I'd be delighted to hear from you if you're interested in any of the material or stuff that I've spoken about here. So thanks again for your attention, and enjoy the rest of Alumni Weekend. So long now.